Okay, let's start. Okay, I can hear myself. Welcome everyone. My name is Mikhail. I'm going to talk about a case study of how we migrated an existing system with long history into Azure Cloud. Please come in, sit down. A bit of stretch first, like put your hand up if you have an Azure account and you logged in at least once there in the portal, ever. Okay, most people. And now put your hand up if you are a backend developer or like full stack developer doing web services, REST services, databases, queues. Okay, good. Seems like the right audience for me. My name is Mikhail. I originally come from Russia. I live in the Netherlands now. I'm a software developer, so I'm going to speak from perspective of software developer, not IT person or business person. My other interests are functional programming, especially F#. Also serverless Azure functions. If you are curious about those, let's chat afterwards, but I'm not going to speak about that in this session. I'm also Microsoft Azure MVP, which doesn't mean I'll try to sell you Azure. I'm just trying to be helpful and share my experience. If I go back like 6-7 years ago, I used to be a freelance developer working from home. Very flexible, no schedule at all, no meetings. I used to do things like go to Canary Islands for a couple of months because winter in Russia sucks. So very flexible. And then at some point 5 years ago, I decided to join a large corporation, move to the Netherlands. The corporation is called Qualcomm. If you've never heard of it, you probably have at least one chip from them in your mobile phone, or at least they paid some royalty to Qualcomm because they have a lot of patents around wireless. And they are very rich, obviously. So when you join a big company, the first thing that you get is a lot of meetings. One of the meetings was IT meeting, when every week we would sit down, we developers would sit down with operations IT guys in the same room, and then we would discuss how everything is going. They would report what kind of problems they have in production with our system. We would discuss the solutions, and then we would also say what we are going to deploy like next month or in 2 months, what kind of new problems they're going to get. And I remember one discussion, our SQL Server wasn't performing good enough, so there was a discussion to buy a new one. We already had like 7 and then a new one. And that's a big thing because first you need to buy some very expensive hardware, then you need to pay licenses for Enterprise Edition, like 7,000 euros or dollars per core. And then you order it and you get it only in like 3 or 4 months because that's a corporate process and so on. So it's like buying a new house or maybe like 2 houses in Lithuania. And also when you finally get it, you're not an administrator on that machine because of corporate policies and everything. So if you need to set up your SQL Server properly, you would call to a DBA somewhere in California, explain them what kind of problems you get, and they would do something with it. Fast forward 5 years, now to do the same operation in Azure, I would go to my source control, we'll edit a JSON file, it doesn't really matter what's there, but it's just the kind of size of text that you need to edit. Then you commit it to Git, you push a magic button in the CI/CD pipeline, and in several minutes you would get the same SQL Server. And it's yours. Of course, you're not administrator on that machine, but you have full permissions to make whatever you want with the SQL Server in Azure. That's the kind of change that we did in those years. So the plan for my session is I start with context, what company is about and what we were doing. Then I will explain how we decided to move to Azure last year. The decision was made last year. And then I'll go through the implementation process, the migration process that we did actually this year. We just moved in like October, 1 month ago, fresh from the press. And I'll try to give some conclusions so that you could use them or my experience in your projects. Let's start with the company, what we do. The first thing is that 4 years ago, Qualcomm sold our division to a company called Astrata. And Astrata is not a huge corporation, it doesn't get a lot of money from patents. So obviously concern of expensive environment immediately got more important. If you look at the business, to explain it in one screen, we do what's called fleet management. So there are vehicles, trucks on the road with trailers behind them, transporting goods from A to B. And inside those trucks, there is actually like a network of devices. There is a device which, a board computer, some sensors on tires, a refrigerator, door sensors, device which tracks what driver does, and so on. And we install yet another device on this network, and it listens to everything that happens, pre-aggregates information, and then sends the most important stuff every once in a while, like once in a minute or two, to the backend. And that's where our application kicks in. We put information into the database, and then end users, transport companies can go to the website and see what's going on and make the decisions. Hopefully clear. To zoom in a little bit on the backend part, we have a web server which talks to telecom providers to get the data. Then we put everything into queues. We have queue processors which get messages from queues, enhance the data, save them in the database. And then there is a web application and also quite some integrations with third parties so that users could use this information. I hope you can kind of relate to this architecture. A lot of applications look like this. Database, web servers, maybe queues for synchronous processing, and so on. So in the subtitle of my talk, I said that we moved €1 million of infrastructure to cloud. Of course, this is not exact number, mostly because nobody knows the exact number. It's lost in years of investments and so on. But to get you some impression about the cost, I think it's not far from that order of magnitude. We had 60 servers, physical servers in the data center, quite a lot of network hardware, like load balancers and switches and very expensive network storage. Then a lot of licensed software. SQL Server is the biggest one. Enterprise is very expensive, but also like firewalls and management tools and so on. And of course, there is ongoing fee for data center vendor and our own in-house IT department to support all this, just the hardware. The hardware was located at the data center. We don't own data center. We hire a data center to host our hardware. That's called co-location. So we own everything, but if you break down the responsibilities, they take care of power supply, cooling, networking, and all about that is ours. So operating system, installing anything like SQL Server, IIS, configuring all that, firewalls, data backups, everything is on our IT side. And on top of that, we have application, which is actually business value. That's the former picture. Now, by the end of last year, we had to make a decision. Basically, the hardware that we got from Qualcomm was going to end of life. There is a cycle there when you get warranty from the vendor. After that, it might still work, but nobody wants to take responsibility to run it without warranty. So it's kind of dead and alive at the same time. And the business reasons were that, the decision would be either we buy all this hardware again, like we have to invest one time a lot of money, and that's something that business never likes. They want to spend money gradually. Or we start migrating to the cloud. A bit more subtle problem was that when we introduced new applications, it was always a problem to find enough capacity on existing hardware. So we tended to plan long ahead in order to deploy a new application. So time to market increased significantly. And on the flip side, if you're gonna go to cloud, then we're gonna spend some engineering cycles on adapting our application. Otherwise, it just worked on the hardware. So that's a trade-off between new features versus development for the cloud. Where do you spend your engineering resources? From the point of IT, going to the cloud is feeling like losing control. You don't know anymore what kind of hardware it runs, where it runs. You cannot do all your trickery that you learned in many years. So it's kind of out of comfort zone. On the other hand, it's much easier to solve problems like multiple environments. We used to have production and staging, and that's all. If you want to test something, you test it on a server under your desk, which is obviously very far from real hardware. In the cloud, you can spin up as many environments as you want, at least in theory, if you did it right. Also, disaster recovery. We had our data center. If it blows up, basically there was no plan. Nobody knows how much time it would take to find a new data center and to move our application there. It's very close to end of business situation. On the cloud, it's trivial, again, if done right. For developers, you are developers, you go to conferences like this, you know that cloud is superpower, you get all the services, all the nice features from cloud vendors. It's very cool to use them, right? You can also leverage the elasticity of the cloud, so whenever your usage grows, you can spin up new instances in the cloud. You can automate everything, so it feels quite powerful. All developers were pro-migration. For everyone, there is also like this feeling of being modern. Not only developers go to the conferences, but also salespeople, and they say that we are running on the cloud. That kind of helps to sell the product somehow. They say so. But for everyone, it's obviously a learning curve, and everybody needs to go out of their comfort zone and do new stuff, which may be hard for people. I love doing performance optimizations, and on the hardware, in best case, like you save from 50% CPU to 40% CPU. This is not the real money save. On the cloud, you might save real money by just making your footprint less. So overall, we decided to go to Azure. There was no real competitive analysis versus Azure versus AWS or Google or whatever. We were mostly Microsoft shop, so that was the most natural way to go. I think that's a large leverage of Microsoft, that they have a lot of companies which think that Azure is the default option. And then they leverage this to upgrade them to the cloud. When we discussed the strategy, there are basically two approaches. We used both, but one more than the other. You can say that we just create virtual machines in the cloud and then functionally copy all the components from physical machines to virtual machines, then make the networking work and so on. It sounds easy, it's not, believe me. You will find a lot of questions that you never thought of in the cloud. How do I can do this? How do I do that? How do I can connect to third parties? How do I spin up like VPNs or whatever? So we decided that wherever possible, we want to leverage managed services like platform as a service in order to be like, don't do heavy lifting ourselves. There is maybe a third scenario of cloud native using something like Kubernetes or serverless, but that wasn't really an option because we were not native to the cloud. We had a lot of legacy code, and it didn't really transfer to the notion of small components in a Kubernetes cluster or especially serverless functions. The same diagram that I showed before, but now for PaaS. So we delegate as much as possible to the cloud. We never manage OS updates or security patches or even backups. That's all on Azure. And we just do our application, okay? It's not just, it's quite a lot of work, as you will see in the rest of the presentation. But at least we do as little as possible. So our strategy is use PaaS when possible, use managed services from the cloud. Every team decides for their own what kind of services or which exact service they want to use. There is no strict guidelines from the company. And we decided that we want to automate as possible. So provisioning, configuration, everything should be automated. One click or several clicks, and then you get a new environment up and running. Of course, the first question when you make this kind of decision is how much it's going to cost. There are several approaches to this. The first is there is a calculator in Azure. You go there, you say, I want this service and this service and this service and this service. And then for every one of them, you say, I want 10 instances of app service, database of this size, that many messaging, that many traffic. And then it will add it up. This is just a sample calculation, not the real one. But the order of magnitude, I think, is correct. And then you get a number. And then the question is, can you trust this number or not? And of course, garbage in, garbage out. If you just click there and you picked something wrong or you didn't think of your scenario quite well, you will not receive a reliable estimate. The way to improve it is, of course, to learn what exactly all those buzzwords mean or those services mean. Then it's always helpful to run some small application. Maybe you have some small, not very important application that you can migrate first. And then you can run it for real in production, like proof of concept, and then see what kind of footprint will you get, which services appear to be more expensive than you thought, which services less. And then make more reliable estimate, extrapolate it on your big applications. The best case is, of course, to measure. So put your real application onto a real environment, simulate a load for a day or a week, and then measure. But usually it's not possible until late stages of migration. So there is a spectrum there. We did all of that at some point. Okay, enough for decision. Now for actual implementation. To remind you about the structure of our application, the building blocks, we have two APIs, one for backend getting the messages from the trucks, one front-end API which talks to end users, and third-party integrations. They are publicly accessible web services on the internet. Behind the scenes, we have queues which get the data, queue processors which crunch that data and produce intelligent result that they save into the database. And of course, there is not just one of those components, but there is like 60 queues and processors, 7 databases, 20 web servers, and so on. Okay. On top of that, there are monitoring because we need to run 24/7, so we need to ensure that we are always up. And deployment, to make deployments easier, we need quite some tooling. I'm going to take these components one by one and then explain how we migrated and what kind of problems we got. By far the most important is SQL Server. It's very expensive. When I say SQL Server, it's not just a software that you install. It's 2 servers because we need reliability, failover. It's very expensive storage, which runs on like a cluster of SSD drives available through fiber connected to the network. Very expensive thing. And then the backup device, where you put all your backups, probably outside the data center, the main data center. So that's all set up. If you look at hardware, that's a sample like screenshot from Task Manager. It has 40 cores, 128 gigabytes, 4 Ethernet adapters, so quite powerful hardware. If you were to move this to Azure about 3 years ago, we checked, it just wasn't possible. They didn't have this kind of machines there. Now you can do pretty much everything. In terms of size, the size of our database was at most 700 gigs, which is important. On the next slide, couple slides. And it's quite a sophisticated database, more than 100 tables and 600 store procedures. So it's not really possible to move this to something like Cosmos DB because it's years and years of engineering. And we needed to keep it more or less intact, but still move it. The plan was to use Azure SQL database because it's fully managed service, and we actually did this. We get a lot of great features out of the box. First, you just ask for a server, get a connection string back, so you don't manage anything. Then they do backups for you. You can restore to any minute in time. You can say, I want a database from yesterday, 5 o'clock. And then in several hours, you will get a copy of the database restored to exactly that point in time, which is handy for like troubleshooting recent problems. You get redundancy out of the box. It just works, magic. And you pay per usage. There is no license fee to pay in advance. License is included into the rent. There are options to move your old licenses in, but we were not able to do this because of laws. I don't know. I'm not good at that, but we were not able to leverage our existing licenses. If we look at the prices, maybe it's too small, but I'll explain. Basically, there is a standard tier, which is just for small applications. We use premium tier. It's from 400 euros to like whatever, 14,000 euros per month that you pay. And if you want to if you want to run a database which is larger than 1 terabyte, you kind of have to use to pay 6,000 per month at least, which was a bit too much for us. So we were kind of lucky that we were about 700 gigs, so below 1 terabyte, and we were quite comfortable that we will not exceed this level. But how do you choose which one to use? The unit of measure here is DTU, which is database transaction unit, which doesn't say anything. You can only say that 100 DTUs is 2 times more than 50, and that's all. So there is a tool that they provide, which you install in your existing production SQL Server. It runs there for an hour or so, measures CPU consumption, memory consumption, network I/O, and then says you need P5. That's it. In our case, we did that. It was a bit optimistic. It kind of guessed the one that we ended up using, but we had to do quite some optimizations before we actually got to run there without problems. So don't trust it completely. A more reliable experiment that we did, roll ourselves, so probably used SQL Server Profiler, where you see all the queries coming in real time. So we made a small console application which listens to production SQL Server, gets all the queries. It's like 1,000 queries per second that we do, quite a lot. Then they throw every query text into Event Hub, which is like a queue in Azure. And we have Azure functions, which listen to that Event Hub. And they replay all the queries in real time on Azure SQL. So it's like real-time copying of all the queries. And then you can measure, and that worked pretty reliably. When we moved to production, it was exactly the same picture. You can get in real time, you can measure what kind of load you get from Azure. And then you can optimize as well. There is a blog post of mine if you Google. If you go to my website, it's easy to find. There is actually a built-in tool by Microsoft, but it couldn't keep up with our load, and it's not very good with Azure SQL. So my solution worked better. But also, there are quite a lot of limitations for SQL database. You have to pick the pricing tier that I already discussed. You cannot switch. Well, you can in the portal. It will take several hours because they will spin up a new server, run the replication from there, and then we'll switch over with some downtime. It failed also a couple of times when we tried, so I'm not comfortable doing this in production. You have to provision a fixed disk space, and then if you use all of that, you're screwed. You still need to do all the index maintenance and statistic maintenance and run your defragmentation jobs and all of that. And there are quite some limitations in terms of features. So distributed transactions, everybody loves distributed transactions. But yeah, they think that grown-ups don't use distributed transactions, so they don't support it on Azure SQL. Just not possible. There is no MSDTC. Anybody using SQL Server Service Broker? You are lucky. Okay, it's not supported. Link servers are not there. You can do kind of remote queries, but they are less powerful than link servers. And you cannot restore your database from a back file. So that's important for migration. A typical traditional migration from SQL Server to SQL Server is like you take a full backup, you restore it on a server. Then while you do this, after that you make a differential backup, which is small. You transfer it to a new server, you apply it. It's relatively fast. You can do it a couple times if you want. And then almost without downtime, you can switch over. This doesn't work anymore. So you can export the whole database in the file called backpack and then import it to Azure. When we measured, it took us 2 days to do this. So 2 days of downtime if you want to go this way, which is not awesome for 24/7 system. So we had to set up a replication schema. Basically, you create a new SQL Server, which is a distributor. It listens to all the changes on the old SQL Server, which is publisher, and publishes all the transactions in real time to subscriber in Azure. That mostly works. We still would do some maintenance after you migrate it, like create foreign keys and switch some options, because again, they are different products, SQL Server and Azure SQL. But I think we were down for maybe 10 minutes with this schema. It also took like 2 weeks to figure out how to configure that. Okay, enough for SQL. Web servers. We had multiple layers, so some web servers are public, they talk to internet talks to them, but the others were inside the firewall, so they are inside this nice cozy environment on our servers when nobody can talk to them. So there is no in between those, there is no security, everybody trusts everyone, everybody should be nice, and so on. We decided to move all of that to Azure App Service, so it's like a web environment as a service. It's fully managed, very nice, very easy to deploy code. You just package it up and send it to them, and then run it for you. You can also do like Git integration. Scale up works this time. You can provision instances larger and lower, and because they are stateless, they will kind of flow smoothly. Scale out is also a great feature, so if you can define thresholds. If your CPU is above 70%, make another instance, and that works like charm. It's also very compatible with all the product like ASP.NET and WCF even, at least over HTTP. So it was a smooth transition. But the biggest problem was that app service is public by default. It's always available to everyone in the world. There is app service environment, which is isolated app service, but it costs 3 times more. So it's really not an option except for some use cases where you really need that security and you have enough money. So what we had to do is to put security on all communication. Luckily in WCF that's relatively easy with configuration. We talk over HTTPS and both client and server has certificate, and then we whitelist them and they know they can talk to each other. It's mostly configuration change, but it takes some time to make it right. Also, if you're using session state in proc or on the servers is not supported, so we had to make a Redis cluster or manage Redis cluster. But that's just one change in web config. So that worked pretty smooth. Now the queues. I already asked about SQL Service Broker. It's not really important, but it's a feature of SQL Server that you can use for queuing. It's pretty hard to use, but it's also very powerful because it sits on the same machine. So it's very, very fast. You can send very large messages there and also get transaction guarantees, which is again very convenient at first. But the plan was to switch to Azure Service Bus, which is a managed service, and you pay per message in theory. And it's nice. We made a nice abstraction layer to switch from SQL Server to Service Bus, and it worked. But we got a lot of performance challenges. First, standard layer, which charges for message per message, it didn't work. It was very slow for us, large latency, also noisy neighbors. We get very different performance on some days on some namespaces. So we had to upgrade to premium, which is at least 500 euros per namespace per month. Then you still get more latency, so we had to batch everything aggressively, make larger batches, do processing of 1,000 messages at the same time. But there is a limitation. The biggest size that you can send in Service Bus is just 1 megabyte. So there is an upper boundary of batching. Also a nasty problem that we got even on premium, like we deploy our application to Service Bus, it works fine today, it works slower tomorrow, it's much slower next week. You erase it, create it again, it's fast again, next week it's slow. So we had calls with Microsoft, we had discussions, they fixed something on their end, we changed some configuration on our end, it started working, we don't touch it anymore. But I'm not really, don't feeling very nice about that setup. So it runs on production, but if we do it again, we would probably look at something like Azure Event Hubs. It feels like we are crossing some boundary of what they can do with Service Bus, although their own benchmarks are allow much more throughput. The queue processors. Somebody needs to listen to those queue. We were smart and we were running a lot of queue processors inside SQL Server on C#. So we write like a store procedure in C# and run it inside SQL Server. It's like probably the most expensive way to run your C# code in the world, but it works nicely because it's exactly inside the same process. and it's very fast. Like it talks in memory with SQL Server. It's blazingly fast. Obviously, we couldn't do this for security reasons in Azure. We are not allowed to deploy code into their SQL. So we wanted to migrate to app service. App service is great, as I said. It can run your web applications, but it can also run your arbitrary console application. And console application can listen to the queue. Awesome. It's called web job. There is a bit of learning curve there because there are multiple layers of what you can do with app service. There is app service plan, which is a scaling unit. So we pay for an app service plan and you can scale it to multiple instances. There are multiple app services that you can put in the same plan. Then every app service can have multiple web jobs in it. And then every web job can listen to multiple queues. So how do you combine this one to end to end to end? That was a bit of a challenge. At first we said, let's do every web job listen to one queue. Makes sense, right? Isolation, if it crashes, nothing happens and so on. But because we had monolithic application, or at least code base, we ended up deploying a lot of code for every process, and then it was consuming a lot of memory, and then it kind of was out of memory for the whole app service, even for bigger ones. So it wasn't that great. We ended up doing a lot of queue processes in the same web job. Then you don't get nice tooling to start them separately and to instrument them separately. But we did it ourselves. We basically created a table in SQL which says which jobs are running, which not. And then it works. If you're just starting from scratch, there is a nice SDK called WebJobs SDK that you can use, which has API similar to what Azure Functions do. So you define a method to be called every time a message comes to the queue. It works nice, but our model didn't really fit into this. Check it before you roll your own solution. Monitoring. As I said, we run 24/7. We have a standby team always on call. In the past, we used to use this third-party tool, doesn't really matter, but it instruments your environment. We get like 2,000 sensors reading everything from CPU, disk usage, to business metrics of how many messages we get from which customer and how much money we earn or whatever. And there is a dashboard, there are notifications in Telegram or SMS or email, and it worked pretty nicely, but it doesn't immediately transfer to Azure. The plan was to use Azure services for this. There are a number of them. Azure Monitor says you how good Azure services are running. For logs, you can use log analytics with search and all the nice charts and breakdowns. Application Insights is more for metrics and events that you can plug your application to. So that looks cool in theory, but it's quite hard to make one picture out of those tools. Azure Portal has dashboards which look nice at first glance, but they are not really configurable, and they were lying in a couple of cases, so we decided not to use them in the end. We use Grafana. Anybody using Grafana? Right. So it's an open source dashboard that you can connect to anything. It has connectors for Azure, it has connectors for PRTG that we used to use. And it's very flexible, it's easy to create dashboards of your liking as a real dashboard. We have maybe 5 or 6 of them. And then the setup looks a bit complicated at first. So we have Grafana, which talks to Azure through Azure Monitor. And also it talks to our PRTG, our existing tools, to get business metrics, because we still keep it there. But alerting is done by PRTG, not by Azure, because we couldn't make it work properly. And then PRTG connects to Azure through a layer of custom written Azure functions. So it looks like this. PRTG is querying a function. It gets the data that we need from Azure and returns the numbers. Again, there is a blog post about this. Probably if you don't use PRTG, you shouldn't care too much. But my point here is that you would probably still need to spend quite some time of your own. There is no one concise story in Azure yet to monitor your real end of life, like business applications. They are changing it every week or so. They are trying to get there, but my opinion is that they are not there yet. Deployments. On-premise, we used to RDP to operator machine, run some PowerShell scripts to copy all the files, change the config files. It kind of worked, stop the services. For database migrations, we use a tool called SQL Compare. It's a commercial tool. Anybody knows SQL Compare? Right, a couple people. Basically, it's desired state configuration tool. You write your SQL scripts in Git in one folder, all tables, all store procedures, and then you say, this tool, please compare these scripts to my database in production. And if there are differences, then make sure that there are no differences anymore. So it applies your desired configuration to any database. It's very useful to avoid like garbage in your database, which appears there over time. A very good tool if you have enough money to buy it. I think it's quite expensive. On Azure, we use Octopus. Who is using Octopus? Not that many people. It's not specific to Azure. It does many things well, but it works pretty good for our Azure deployment. I can't complain. We also migrated all our infrastructure to ARM template, Azure Resource Manager template. So you write a bunch of JSON, you describe your environment. There are some variables here and there so that you can create multiple environments by just swapping them. And then you run a command and your environment is up. Next time you change it, you can say, please apply this to existing resource group, and it will, in theory, apply all the changes as you wish. There are some buts. It's not perfect again. Behavior of different resources differs, so you need to learn it again. If you want to learn a better way to do so, there is a session today at 3:30 where you can do the same, but not with JSON, but with TypeScript. It's very cool. Go there. Naming convention. When you create hundreds of resources, you should agree with other people how you're going to name them. That's our convention, which nobody is happy with. If you look really closely on this name, you will see that there are 5 parts of 3 letters, and every one of them says something. But it's a bit like looking in the matrix, all those symbols going through the screen. Like you need to tune your vision to see the parts. We don't use dashes because I believe storage accounts don't allow them, and then we decided to make it universal. But it's not really great, especially for newcomers. Maybe a better approach is to create multiple subscriptions. So create a Azure subscription for every team, and then every team can decide on the convention for themselves. Subscriptions are free, so it's easy. We kind of mitigate this problem with tags. We use tags a lot. Again, they are in JSON of ARM template. And you can say, this is environment production, this application, and describe it a little bit. And then it's possible in the portal to search by tag, to filter by tag, to get billing by tag. So it's very, very convenient. Okay, to wrap it up, the conclusions. So is migration on this kind of application possible? Yes, it's possible. We did it last month. It's running in Azure. Was it easy? No, because we spent quite a number of months of engineering work and testing and consultants and everything. So I would say while you are there, if you decided to do this, leverage cloud services as much as possible. They will help you. Use this time to clean up some old debt that you have in your code base, and also automate everything as much as possible. That will help you in the future. So is there no upfront investment? Yes, if you don't consider the testing period and the money you spend on testing. Is it cheap? Probably not really. If reducing the monthly price is your main motivation, maybe you should think twice. It might get cheaper over time when you know how to use it properly, but on the day one, it's probably going to be quite expensive. And don't forget all the money that you're going to spend on learning, on testing, on changing your code, on hiring some third-party consultants for security or what other aspects that you don't know. But there are also good things about pricing. In our case, I believe during build this May, they had this blog post with fancy name, but the idea is that on that day, the prices of app service that we were using dropped 20%. So we save 20% of all our compute just in one day. Business people are happy. It probably means that we were paying too much before that, but that's a different story. So is cloud fully managed? Yes, it is. You don't manage hardware or virtual machines if you don't want to. Is it always up? No, because Azure also has outages and other cloud providers, obviously. If you go to Azure status history page, you will see all the reports about different outages in your region or in any region. In my experience, they are a bit reluctant to put all the information there. They're like trying to minimize the publicity, but it works very well if you were down because of that, and then you can send your customers to the page. You kind of can relate why you had downtime because of Azure issues. Also, if the whole region is down, then you cannot actually do anything. You just grab a cup of coffee and open the Twitter. This is a real feed of Twitter during Azure outage. Like checking your monitoring and waiting when it just will be up again. The bigger problem is when everybody is up and you are down. That also happened. A real story, we were running on production like first week, and then we got some alerts from monitoring. We go to the portal to check our SQL Server, and our SQL Server is not there, like it's not shown on the portal, it doesn't exist. So you invest in support plan, we called them, they fixed something, it appeared again, no data lost. There was some race conditions, they said, and blah, 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 but be prepared to this kind of work as well. It's not perfect just yet. But overall, I would say our experience is positive. We are running for about a month, and we are happy with what we achieved. Thank you.